Harrison, can you hear me?
Yes, sir.
Okay. Be mindful, we're in a different lab and I'm struggling with settings again. So whatever you say is broadcasted on the speakers, which is not bad, right? It's not.
It might actually be a good thing if I'm asking a question or answering a question.
Oh, okay. I'm sorry, what did you say?
I was saying it might be a good thing if I'm asking or answering a question.
Yeah. Actually, I think people can hear you for the first time through the speakers. Okay, Quincy is here as well, right?
Yep.
Okay, the last hurdle to jump through, I'm not getting a push notification to my cell phone. Okay, friends, sorry for a late start again. I was actually a bit worried that we're going to have a bad technology day again, but it looks like everything is working, so I was able to set everything up. My last hurdle was my cell phone trying to get this push notification. For some reason, it's not getting Wi-Fi. It's not getting cell phone signal here, so I used Wi-Fi. Okay, welcome back. So how is everybody doing? Doing good?
All right.
Okay, all right.
Doing
What about
good.
you, Quincy?
I'm doing good.
You're doing good. Okay.
How about you?
I'm okay. I'm okay. I think for the last couple of weeks we're getting those first signs that the coronavirus pandemic is coming to a conclusion, right? Because there are less cases worldwide. However, there are still those Alarm is those people who are saying that there are new strains coming up, strains of COVID-19 coming up, right?
Yeah, but there's the
Yeah.
third vaccine for everybody. So
Yeah, actually, I'm a bit disappointed like with what's happening in Kentucky because I have friends like in Texas and Florida, they all got their shots already. And for me, like I'm not even like even aware like when they're gonna be doing it.
Well, if you're a teacher, you shouldn't be able to get them.
No, they're not doing it to college.
Really, my mom, she's a elementary school teacher.
Well, they did it for elementary school teacher like as a first priority, which I understand. But I don't understand like why all of my college professor friends like in Texas and Florida, they already got their shots. Well, for me, there's not even a schedule. Well,
Dr. David Signoni is maybe not a doctor, but a professor here. He has an appointment for Wednesday.
well, it depends. Like if you're over 70, or if you have some chronic
He is
disease, you know, maybe
going
he's in those other categories, right?
Well, you know, here it's a little slower for everything. So.
Yeah, but they make it sound like they're like way ahead of the curve, but it looks like they're way behind with everybody else. Well, anyways, let's hope things will improve. I think just like everybody else, I miss normal life. Friends, today's agenda has the following topics. Number one, we will talk about reading data into R. Okay. If you're doing a research project in R, that will be your first step to read data. And then after you read it into R, you can start cleaning, you can start manipulating, you can start summarizing, you can start looking at your data. Okay. I would like to step back a little bit and give you an overview as to what we're going to be doing over, until the end of the semester. And for that, I will open our individual project description file. By the way, Quincy and Harrison, how is the sound? Can you hear me well?
Yes.
Yep.
Okay,
Perfect.
good. Let me find that individual project file right here. 1 second. Remember this diagram that I showed you earlier? So this is an overview of the so-called data science process or research process in general. I think we're here right now because it looks like all of you have identified a topic for your research project. Okay. Overall, I was pleased in a sense that I understand what everybody is doing, which is good. So we can start working on it. But of course, you know, people have put different degrees of thought into the research topic. But again, I know what you're doing, which is good. We can get started, right? I would recommend to some people, and we'll come back to this to this feedback again towards the end of the session. But I would recommend some people still to narrow things down a little bit, not to boil the ocean, and give some suggestions. Or maybe I should do it right now since everybody's here. A couple of things I would like to say, like for Quincy, I think he is all good. You know, he put a bit more thought into what he's doing. I think he has read some literature about racial discrimination and things like that. So now he seems to be in a good shape to start working on this topic. I'm curious what you will find. For Jude, in a way, I have no problem with it. Like, you know, I know what you're doing. You're going to be using this credit card transaction data, right? I'm a bit, I guess, puzzled that you're jumping from one field that you have no expertise in to another field, right? Because you're not a financial or security
I
professional.
did work as a financial compliance officer in a financial company. So I do have like 1 year experience.
So you worked everywhere in all industries, in
I did,
healthcare, in
I'm
HR, in
about
IT. Well, again, I'm not saying what you're doing is bad. I'm a bit worried that you're working. I'm a bit worried maybe.
I did not want to change it. I tried for the last minute because most of the data, because I told you we're going to work on EP. There's not enough data. Most nursing homes, they don't put the data. It's empty.
Well, I looked at it. There are many empty observations, but you can still get many
It was
thousands.
very few, like 70 out of I don't remember, like very few. Whatever I
Okay.
tried to, and it didn't work. So that's
Okay.
why I changed it.
And the other thing is machine learning. I mean, again, that doesn't seem to be your area of expertise, machine learning. It's a big field. I guess you can do things in R because there are packages out there. I'm just saying I'm a bit worried that you're getting into machine learning. Do you have any background in machine learning?
Just the classes I took here.
So where did you cover machine learning? In which class?
What's the first class that we used visual? With Dr. Solomon, I took the class that we used.
Is it 650?
Yeah.
Okay. Well, if you have some understanding what machine learning is, I guess that's a good start. So overall, I have no
Precision
problem.
should work, sorry.
I feel like you're jumping from one field to another where you don't have expertise, right? So that's how I feel. But
Don't
again,
worry, I
it's
won't-
not a bad thing. Maybe you'll learn something within a new area.
My dad was actually a professor in finance and investment, so I grew up with that.
Okay, but I hope it's not going to be your dad doing it,
No,
right?
he's dead.
Oh, I'm sorry.
It's okay.
Nate, sounds good. I mean, what Nate is doing, he's correlating weather factors, like it was temperature and humidity, something like that.
I think I found an R package from the website I
Mhm.
was using to get on my historical data, so
Okay,
I just have to figure out how to import it and turn that data into.
historic data about weather and baseball game attendance.
Well, baseball game attendance, I'm getting from a different website.
Okay. Well, look, this is what I wanted to tell you. On the one hand, I like what you do. I mean, not on the one hand, but in general, I like what you're doing. It seems to be like a very narrow topic, right? So you're correlating two variables or several weather variables to Major League Baseball stadium attendance, something like that. Makes a lot of sense, right? It's clear, it's simple. I was a bit concerned that just like Jude, you're getting into something that has no relevance for your life or career. But you told me that you're thinking about becoming a sports analyst or something like that. So maybe it's a good thing, right? The word of caution I would like to give you is this. I had a student, I think I mentioned his project before. He was trying to correlate weather in Chicago to crime statistics, right? And it took him almost the entire semester just to get the data set.
Oh,
Doing the analysis was an easy part. And he ran this regression. I think he did it like in a couple of days. But getting all this data in was a huge project. By the way, I'm not surprised. Research shows that in data science projects, up to 60% of time is actually spent sourcing and cleaning data, right? Which is not surprising. I think for him, it was like 80% because it's only towards the end of the semester where he said, oh yeah, I have the data set to start analyzing it. And again, I was worried about it, right? So the kind of problems that he came up with was this. For example, he has like crime data for, I don't know, let's say weekly basis in Chicago, right? And then he has weather observations like for every hour, right? So he had to somehow aggregate and compile. By the way, we'll learn in this class how to do those things. But I'm just saying, I'm a bit worried about the data portion of your
yeah,
project.
I found what was on the website, so I don't know if the package will have it, but on the website, it lists the high, the low, the average temperature, the average wind speed, the percentage of the amount of precipitation and the humidity for the day,
Okay.
which is all I need, and they're all listed by day, by month, and then all the baseball games are just listed, you know, when they're played.
So it's a different data set, right?
Yeah, it's a different
Okay.
data set, so I'll just have to find a way to merge the tables.
Okay, so my suggestion to you was to start working with data SAP, and it looks like you're already working with data. So
Yeah, I haven't got them into R, but the one website I was looking into has an R package, and if that R package doesn't work, it has an API, so I could still use the API in the worst case scenario. It just gives out.
well, I'm not sure what you need the API for. As long as you have this data like in an Excel or CSV format, you should be able to read it.
It gives out the stuff in tables. So worst case scenario, I just go month by month and then import it.
Yeah, and start with a small pilot, maybe full. I don't know what exactly you're doing, but maybe for one team or one stadium,
Yeah,
and
I'm
then
gonna do one team for 2019, and just because that's 82 games at home.
just keep in mind. Let's say if you have, let's say you have two predicting variables. One is temperature, the other one is humidity, right? Just a rule of thumb, it means that you need to have a sample of 200 observations approximately, right?
Oh, I could stretch that out. If I go back more years, because just doing it in 1 year won't like other factors. Like if I do like one team back, like even 5 years, that's the sample.
Just make sure you shoot for roughly 100 observations per independent variable, something like that, right? It doesn't have to be that strict, but approximately that's what we're looking for. Okay, so good start. Again, my suggestion, start working with data as soon as possible, because you may be surprised how difficult it is to find and match. It sounds like simple, right? Baseball plus weather, but it may be actually difficult to find and match all the data. For Harrison, I like your write-up a bit better. I feel like it's still like not specific enough. Like last time, your research question was like, oh, so what is it like to work in computer science field? I mean, that was too general. Now I remember you have more specifics. You're talking about like specific professions and things like that. I still feel it's a bit too broad. I mean, I wish you have like a very specific research question in relation to computer science employment. Okay. On the one hand, I have nothing against you doing like an exploratory approach. Like exploratory means you're not trying to correlate anything. You're not trying to prove anything. You're just trying to explore different professions, right? But I wish like that exploration was like a bit more focused and more fine-tuned, right? Again, I'm just brainstorming on the fly. I'm not sure whether those are good ideas, but just one suggestion. How do IT skills determine somebody's pay, something like that? So what you can do, you can build, let's say, a regression model that takes into account all those skills that people have. By skills, I mean like different tools and programming languages and how all those things impact your earning. Again, what I'm trying to say, try to be more specific. I mean, in a way, I feel comfortable. I understand that you're trying to explore data, and maybe when you start exploring this data, you will come up with specific ideas. But my suggestion, and again, I'll leave it up to you. I'm not gonna run after you anymore. I mean, my suggestion, try to first of all, look at the data more, download the data, look at it, import it into R, see what's available there. Number one. Number two, read some papers about professional issues in IT. Maybe you'll come up with something interesting, something narrow, right? This is what I came up with. I've been reading like some articles about employment issues in IT, and I came across this idea of ageism in the tech sector, where like all those technology leaders like Mark Zuckerberg saying that, oh, young people are just smarter. And, you know, from my own experience, I know that writing code is really, it's like a profession for young. I mean, once you hit 30, it becomes a bit harder to learn new tools, like new technology. So I was really interested in this question, like what happens to older developers, right? When they get older, what, do they get fired? Do they get paid more? I actually explored this question on some discussion forums. Like some people were saying that indeed, when you become older, your sharpness declines, and which is more important, you have more family responsibilities, so you cannot code 12 hours a day, but you compensate that through knowledge and experience, where you make less movements, less mistakes, and things like that, right? So that's something I came up with that was related to my exploration of employment issues in IT. So again, I would like to suggest that maybe start working on this, start looking at data, start reading things, and maybe you'll narrow it down to something more specific. Okay. What do you think?
Good. That sounds good.
Yeah, because I mean, it's still like what you're saying, it's a bit too broad to me. I mean, try to focus it on something interesting, right? And then when you focus, not only you're making it more interesting, you're also kind of making your project a bit less in scope. Okay. So you're free, like if you don't like the grade that you receive, you're free to resubmit your write-up, right? I mean, as I said, overall, I feel like everybody has done well in a sense that you know what you're doing and I know what you're doing. But if you want to improve your write-up, like think a bit more, think about your topic more, feel free to do that. Okay. So we're gonna have another submission rounds. And again, please do me a favor, because I'm a victim of spam. I'm receiving so many notifications. If you submit your write-up for another review, just shoot me an email in Canvas saying that a new submission has been made, something like that. Okay. So that's my feedback to you. Again, thank you for doing this exercise. Sorry if my criticism was harsh. Again, my concern is that people do something that they can do, right? I mean, they select something that is small, clear, and doable within one semester. If your intention is to solve the current COVID-19 pandemic crisis, that's a good goal, but that's kind of outside of the scope of this class. It's too big, and that's something we cannot do with our studio and with the data that we have. Okay, so that's my figure. So going back to this diagram, so from now on, we'll go through all of those steps. So today we'll talk about sourcing data, that step. So you all have research questions, more or less, right? So we'll talk about sourcing data. Next class, we'll talk about tidying data. We'll talk about working with strings. We'll talk about grouping data. We'll talk about filtering data. So that will be our topic. After that, we're going to have midterm exam. Okay. By the way, I already posted it here. One second. I will just show you the exact date. So today we'll talk about reading data into R. Next class, we'll talk about working with strings. After that, we will have a class called group manipulations with dplyr. So this is the filtering, the data cleaning part. And then I will ask you to take midterm exam. This is like a fairly short topic. I think it's not going to take us 3 hours. So instead of, because the thing is we cannot lose a week because we're already losing a week on the 30th. I don't know whether you remember, we have this on March 30th, we have this, what how do they call it?
ATI.
Yeah, non-instructional day or something like that. So I don't want to lose this week and then another week due to midterm. So we're going to talk about group manipulations, and then I'll give you time. I believe it's until Monday. Let me check, March 16th. Actually, March 16th is Tuesday. Well, I think what I did, I said it like before class. So you need to take it before you come to class, right? So you'll have until March 16th to take the midterm exam. Oh, I'm sorry, it's March. Yeah, sorry, I made a mistake. So it's March 6th. Okay, so that will be on March 16th. And then the midterm exam will be due on March 22nd, which is Monday. So after our lecture on Tuesday, you'll have a week to prepare for the midterm exam and take it. Okay, so that's the deadline. Here we have midterm exam review guide. We'll talk more about it on the 16th, but you can start studying for the midterm exam. All the chapters from the book that will be covered and all the topics are listed here. So those are the chapters from which questions will come from. We'll have approximately 50 multiple choice questions. One thing that I'm allowing you is to bring an A4 cheat sheet. Since you will take this exam at home, right? You can have a paper with you. By the way, the exam will require you to use lockdown browser and a web camera. You know what I'm talking about, right? Have you done it before? Taking exams with a web camera. So it's called like Respondus Monitor. So one thing that Respondus Monitor asks you to do is to show your surroundings, like to show like what's around you. And I'm fine if you have an A4 cheat sheet, right? It's like a sheet of paper where you can put anything that you want, okay? The reason for this cheat sheet is that like a lot of programming issues, they're like, I guess, memorization based. So I don't want this class to be like about you memorizing like every function. So feel free to create notes as long as it's like one A4 sheet. You can write, you can draw, you can scribble, you can print anything you want, right? The only rule is that, well, actually 2 rules. It has to be an A4 sheet. It cannot be 2 sheets or 3 sheets. It cannot be like a 3 sheet, right? Bigger one. And number 2, you cannot copy from each other. So everybody has to have his or her own cheat sheet, right? You cannot just have one person preparing a cheat sheet and giving everybody a copy, right? Because I also think that by creating this cheat sheet, you will also review things. It's like a study, an additional studying opportunity for you, okay?
How did you like submit this cheat sheet?
No. Well, I trust you, like I trust you that you're not going to be doing something.
Yeah, but how does the camera notify you? Like to put it and show it? I don't know.
That's fine. I mean, I trust you. I'm just saying, don't do anything beyond that, right? Because I mean, I just don't know. But if you do something beyond that, maybe if you bring a book, maybe it will catch you or something, right?
So you will take it on 22nd.
The deadline is 22nd.
It will be open from 16th. to
Yeah.
22nd. Oh.
Yeah.
Well, in other classes, they open it for 1 day. That's why I'm surprised. It's open for more
Well, I
than
want to
1
give
day.
more flexibility. I mean, I feel like it's an upper level course, and I don't really suspect that somebody has an intention of cheating or something like that, right? Maybe somebody does, and maybe we'll catch that person if that person does.
But that's all multiple choice.
Yeah.
For this cheat sheet, is it okay if we do front and back?
Yeah. Yeah.
Okay, thank you.
Yeah. Both sides, as long as you don't staple like 2 sheets together, or who knows what else you'll come up with. As long as it's 1 sheet, you can do anything that you want with it. Okay. And here we have all the topics. So basically, it's everything that we've covered so far, with the exception of that last part: string manipulations, group manipulations, pipe operators. We'll talk about pipe operators as a part of our string manipulations lecture. And then our markdown language is something that we have covered. Okay. Okay, so next week we'll talk. Today we'll talk about sourcing data. Next week we'll talk about tidying data, right? Organizing it, and then we're gonna have a midterm. After the midterm, we'll go into analysis. So we'll talk about visualizing data. We'll talk about ggplot2. We'll talk about exploring data through descriptive statistics, and then we'll look at some of the main analysis techniques in R. I think, well, actually, I'm sure we'll start with regression because this is the analytical approach that I think perhaps at least 2 or 3 of you will be using for their own project. So we'll start with that, right? And then after that, we will also talk about text mining, and we will also talk about machine learning. We'll look at some examples of machine learning in R, but that will be towards the end, okay? So after that, you'll be on your own in a sense that we don't have time to cover anything else. So if you're doing anything outside of those techniques, you will have to explore things on your own. But again, I feel like in this class, I will show like all the, the entire toolbox that everybody needs for his or her research project. And also what I'm trying to say here is that you need to start working on your research project this week. You have all the tools, the basics of R syntax. You should start working on it. You should create an R Markdown file. You should start at least maybe writing an introduction. You should start reading data, importing data, cleaning it. And again, within the next couple of weeks, you'll have all the skills for importing and cleaning data, okay? So that's what we are doing until the end of the semester. And I believe I already entered all the deadlines in Canvas. There may be like some small adjustments depending on how things go, but more or less everything has been entered. And I apologize for those false alarms, for those, people were asking me like, oh, is midterm due today? I apologize for that. To be honest, it's very complex on my side. You know what's happening right now? I have this course running, right? In parallel, I will have the same course, meaning the same course that you're taking right now. It will start on March 15th, and I will run it in a 7-week format, okay? So I'm rearranging and everything, exporting, importing everything, and that's how I kind of got lost a little bit with those things when I'm importing, exporting quizzes and exams. So now I believe everything is straightened out, so thank you for your patience. Okay. So now we are going to what seems to be the main agenda for today. We'll talk about importing data into R. And there's a technical problem on my computer. Java is not updated, but I don't know how about this one. So we'll see what it will actually like. Just like one little example may not work in my demonstration. So we'll talk about first we'll talk about reading data from files into R. So that's the first subtopic that we'll cover. And after that, I'll ask you to take a short quiz based on that lecture. Okay, nothing, specific. You just need to pay attention to what we're doing, right? So I'll start with this code example. So I'll go ahead and open this code, R code file in RStudio, and just save it where you can access it. And then we'll go through this code example. So I'll put it on the desktop. By the way, I requested R and RStudio to be updated in NetLab. So I think it's updated across all labs. That's how they do it. They have like one single image. So we'll see today whether it's updated or not. Okay, so were you all able to open this file?
Yes.
The one that I have, but you don't see RStudio on the screen, right?
I did until just a second ago when you switched.
So can you see RStudio now?
Yes.
Yep.
Okay, great. Okay, so do you all have this file in front of you? Did you find it?
Oh, absolutely. No.
What about you, Nate?
Yeah, I have it.
Okay, good. So we'll wait for a second. Did you find it?
Yes,
Okay. You have it in RStudio?
yes.
Okay, so it looks like everybody opened that file. So let's look at some examples. And I think for most of you here, that's all you need. Like today's class is all you need to read your data into R, to open your data in RStudio. So first, let's talk about opening CSV files. As you probably well know, CSV stands for what?
Comma separated files.
Yeah, comma separated values, right? It's a very popular file format, especially on the web. All it is, it's a text file, right? It's a text file where data is stored, and those data points, as the name of the file suggests, are separated using commas. Now, sometimes it's not comma, sometimes it's something else, sometimes like it's a space, sometimes it's a semicolon, right? But collectively, those files, text files with data, where data points, meaning individual cells, are separated with something like a comma or semicolon or white space, are called comma separated values. By the way, Excel recognizes those files as well. So if you have a CSV file, you can easily open it with Excel, right? And many other products. For example, you can open it with Microsoft Access. But Microsoft Access will run a wizard that will help you specify the rows and columns, and then it will read it as a table, okay? Very popular format. So what we will do, we'll try to read data from a CSV file that is published online by Jared Lander. That's the author of your textbook, okay? So what we will do, we'll save the URL pointing to that file in the variable called the URL. Okay. So now that the URL variable, as you can see here in the environment, it contains a link, a web link to this file. And then we'll use two functions, read table and read CSV, okay? As you can see, both functions are identical. They look identical. The parameters look identical. To be honest, I don't know. I'm not that sure what's the difference. I think CSV, is a function that is optimized for working with CSV files. So maybe it will be a little bit faster, but again, for most of us, it won't make any difference because we're not dealing with huge data sets. For example, if you're dealing with huge data sets spread out across thousands of Excel sheets, then maybe the usage of CSV, read CSV function will give you an advantage, right? If not, if you're not dealing with those kind of data sets, probably those functions are interchangeable. So we'll use read table command. We're saying those are the parameters. The file is the URL. Header is true, which means the top row of that file is a header which contains column names, right? If you don't have column names, then the header will be false. And then separator, what kind of separator is used in that CSV file is a comma. As I said, it can be a white space, it can be a semicolon, but in our case, it's a comma. So we'll read the data into tomato1 variable. So tomato1 now is a data frame, right? So if we try class, it's a data frame, right? Look, when you click on tomato like this, it will open the data in that kind of Excel equivalent in RStudio. It's like a data explorer. So you'll see that this is the header with labels, and this is the data that you have. So you can explore data quickly like that just by clicking on the data variable like this, right? And then we'll read the same file into tomato2 variable using read CSV function. Again, the parameters are the same, and we get tomato2 that contains 16 observations of 11 variables. As you can see, the data is about tomato, different tomato breeds, right? So that's why it's called a tomato data set. So you see those two functions, they work the same. If you just run tomato1, you will see what's in the data set, and the same thing for tomato2. But usually, to get a sense what the data frame contains, we use head command. Remember, to see the first how many entries. Do you remember? So by default, it will show you, I think, 6. Sorry, I made a mistake here. So it should be like tomato1. We don't have a variable called tomato. So I think by default, the head variable shows the first 6 entries. And if you want to see the last one, the last 6, you will use what?
Fail?
Yeah, I think it's spelled like this, right? Yeah, so you'll see the last 6 entries. So as you can see, you can read as long as you have a CSV file, you can read it with one simple function, okay? And you'll have a data frame that contains all of your files. Now, next we'll talk about reading Excel files. Now things may become a bit tricky here because I'm not sure whether I can run it here, because today I couldn't run it on my computer, and I'm one of those people who don't have full access to my own computer because it's a work computer. I need to ask our IT director to install any updates, okay? And I didn't have a chance. So look, this is what we will do. First, we will save that CSV file that we worked before somewhere where you can access it, okay? So what I will do, I'll save it to the desktop. So I'll just copy this URL. Then I'll open this URL in a browser. Hey, guys, do you see browser right now if you're joining us in Zoom, or you still see RStudio?
I still see RStudio.
Yeah, let me switch 1 second. Yeah, so what I will do, I'll just run this, I copy this URL, I run it, and it will ask me where to save file, and I will save it to my desktop, okay? Okay, now, do you see my desktop?
Yes.
Okay, so do you see tomato file here?
Yes.
Okay, good. So what I will do next, I will copy the full path to this file. So I'll right click and then click on properties. So when I click on properties, I see that full path. It's C users vcrowd of desktop. Okay, so I will copy it, and you should do the same. Copy the path to the file where you saved it. You know, in your case, it may be somewhere else. So I'll go ahead and copy it. Okay, so now I'll go back to RStudio. Do you see RStudio on the screen?
Yes.
Okay,
Yep.
great. So I figured out how to keep it locked on this monitor. So what I will do, I will insert that full path as a string here so that my working directory variable contains that full path. By the way, there's one trick. I always forget it myself, and I see a lot of people quite often forgetting it. In R, that should be a / when you're using a path. In Windows, it's /. So you need to change it to /, as otherwise it won't work. So I'll set my working directory to desktop because this is where the file is. So I'll run these 2 lines of code. Okay, so it works. And then when I use get working directory function, that function retrieves the current working directory. It shows, okay, right now we're on the desktop. Okay. And then I will try installing the Xlsx package. Again, I don't know whether it will work on this computer, but I will try. So I'll install the Xlsx package. This package contains everything that you will ever need for working with Excel files. Okay. So let's install it. Okay, so now I installed that package. It should be somewhere here. So let me find it. Okay, I installed it. The problem is running it. So if I select it, okay, so it looks like it will work. We'll see. So what we will do, we'll save the file name tomato first into my file variable. Okay. And with this read Xlsx2 function, because that's the function from Xlsx package, we'll read the contents of that file into Xlsx _ data variable. Okay. Now, one thing to show you, just 1 second.
you know what to do when you're getting
Java error?
I just have to install Java.
Well, I'm not sure whether you can do it, whether you have those privileges. That's the problem I ran today into my computer.
I'm on my own laptop.
Oh, you're on your own laptop?
Yeah.
So you just look at my demonstration. I mean, we're not going to spend too much time here, but once you update Java, you can Google it error, but what they're saying, it's you don't have the 64-bit version of Java installed. That's why. Maybe you can do it quicker. Now, as you probably well know, at this point, at this stage of your career and studies, based on your experience with Excel, Excel files are called workbooks, right? So each Excel file is called a workbook, and workbooks are comprised of what? Yeah, sheets or worksheets, right? So look, this is one advantage for you of that Xlsx package. You see here, you're specifying that, okay, that's the file, that's the workbook that you're reading, but you cannot read all of them at once, right? So you're reading sheet name, tomato first. In other words, this first tab right here, tomato first. So that's one advantage of, just like not even advantage, but demonstration of Xlsx package functionality. You can read specific sheets from an Excel workbook, okay? So we'll read it like this. Okay, what happened? Oh, we need to save. Yeah, I haven't run this first line of code. I cannot find what happened. Yeah, that gives me an error. Let me try to figure out on the fly. Were you able to read your Excel file with this command?
It gave me the error too.
I don't have Excel on my home or on this computer. I can do
Oh,
that.
you know what? Maybe because my file is open, I'll try to close it. Maybe that's what's giving me this error. Just cannot find tomato. Oh, let me check the file name. Oh, it's CSV. That's the problem. So we saved it as a CSV file. Let me change it to Xlsx. Okay, so let's try to do it again. Okay, now it gives me the Java error. Okay, well, that's what I was afraid of. There's there's still something wrong with Java because apparently that Xlsx package is based on Java, and unfortunately, I cannot update it on the fly. You can quickly Google, like if you're getting something like this on your home computer, you can quickly Google it, and most likely people will tell you something that you need to update your Java, right? So unfortunately, I cannot do it. So you have to trust my word that this is how you read a specific Excel sheet using Xlsx package. Okay, what about you, Nate? Were you able to update Java? What happened?
I'm working on it.
Okay. Well, anyways, yeah, I couldn't make it work on my home computer too, on my laptop, because I cannot update Java. So you need to trust me that it works. This is how you read it. You just need to figure out why this error is displayed. And again, my guess, I'm 80% confident it's due to Java update. Okay. So this is working with Excel sheets. By the way, I mean, if I were looking for a quick workaround, if you have simple data, right, where you don't care about formatting, what I will do, I would export an Excel workbook one sheet at a time. I would export it into CSV files and just read it using the read table command, right? So that would be like one workaround if I had to do it right now. Okay, so next we'll talk about working with databases. I'm not sure, I don't think anybody will do it. Personally, I've never done it. Like I've never used RStudio in conjunction with databases. And that's why just like a quick mention, there is a package called RODBC. And if you took a course on databases, you probably know that ODBC stands something for Open Database Connection, right? That's what it stands for. It's a standard for data interexchange between or among databases, but usually it's between a database and an application that is using the database. So in R, there's a package that can do that. So I'm just saying, if you're retrieving data directly from a database, let's say you downloaded your data in the form of a Microsoft Access database, So this is the package that you need to get the data directly from Microsoft Access database without having that workaround where you export it into Excel or CSV. By the way, sometimes people use data from in other file formats, specifically coming from various statistical tools. For that, you need a package called foreign. So yeah, I installed it. It looks like it works. Yeah, foreign right here. And foreign package has a collection of functions for reading data from various statistical packages into R. For example, if you have an SPSS file, that's another application that I'm working with, then use read SPSS function. If your data comes from Stata, which is another popular software package for statistical analysis, then use read DTA because that's the file extension for Stata files. And if your data comes from SAS environment, I work with SAS very briefly. It's a huge like corporate level data analytics package. And there's a function called read SSD. Okay, so that's all. I think with that, you can, with this toolbox that you have, you can open any kind of file out there, including a database file. Okay, now let's talk about using R binary files. Now, R binary files, they have the following extension, R data. So that's something you need to memorize. You need to remember that it's called R data. Okay. So what that file is, it's a binary file. And typically that binary file is used to store a data set in a native format for R and R Studio. Okay. Let me show you how it works. You can save your data frame called tomato1 into a R file with R data extension. That's your R binary file. And for that, you use that save command. So you're saying save data frame tomato1. Save data frame tomato1 into an R data file that has a name tomato1.rdata. So when we do that, here it is. It should be somewhere on the desktop. Where did I save it? So let me try it again. Okay, here it is. It's on a different screen. So this is the file, tomato1 R data. Now let's see how it works. Let's say we remove tomato1 from memory. And for that, we use rm remove command. So when we remove from memory, it will disappear from that environment window. So now it's gone. So if you try to access tomato1, it should give you an error. But what you can do, you can read the data frame back in using the load function, but you will load it from that file, not from anywhere else. Okay. So now it works. So we loaded the data frame from that R data, R binary file, and now we can work with tomato1. Now, why you want to do something like that? Well, because it's much faster. You see how quick it is to open a data frame from that R data file. I actually run into those problems myself where you have a very elaborate script just to read the data. Usually it happens when you're reading, let's say, something from the web. Okay. So for example, I had scripts where, let's say, I have a data frame with 40,000 records, 40,000. 40,000 records in a data frame, it's not that huge of a data set. It's a big data set, but it's not like big data, right? We're not talking about big data with 2 capital words, right? However, to get that 40,000 rows in a data frame, I need to spend around 12 hours. So that's how long it takes for the web crawler to access the website and create 40,000 entries, right? So you see, every time I'm running my script, I don't want this data to be reloaded from the web or from files, right? So instead, what I will do, once the data frame is read, I will just save it as a binary file. And then next time I will just open it from the binary file because I don't want to relaunch the crawling process each time I need to load the data. Now, I would imagine that if you're doing something sophisticated, like, if you have like several files, like maybe in Nate's case where he's matching several weather files against several files containing baseball statistics. Again, you may not want to rerun this data input stage every time you run your R script. So for that, you will create like an R data file, and once you read everything, you will just store it there. Okay. So the bottom line is just like it's much faster to store data sets in an R data format. And then one small comment. In this class, we'll be using a lot of built-in data sets. Now, those data sets, they come with certain packages. For example, we'll be using a lot of data sets from the ggplot2 package. That's the data visualization package. It's a vast collection of visualization tools. And two data sets that we'll be using quite often one data set is called diamonds, which contains data about diamonds. And the other data set is called MPG, which contains information about different vehicles and their fuel consumption captured with MPG variable. Okay, so for those variables, as long as you have the required package activated, you just use data command to load it. For example, let's see whether we have ggplot2 installed here. No, it's not. So we need to install ggplot2. Let me try doing it right here. Probably take a couple of minutes because it's a big package. Okay, so this package should be there. 1 second. So yeah, once you have that package installed, you should have access to those data sets, diamonds and MPG. So when I run data diamonds, you see the diamonds is loaded. For now, it's just like a value of the data set. But when you use head, it appears as one of the data structure variables. So as you can see in this data set, you have 53,000 observations, okay, of 10 variables. And the same thing with MPG. You load it using data command and use head command to look what's inside. As you can see, MPG is a much smaller data set. It has only 234 observations of 11 variables. So we'll be opening a lot of the diamonds and MPG data set, especially when we talk about ggplot2 package, okay? Okay, friends, so those are the main approaches to opening data into R, reading data into R. So once you read data into R, you read it as a data frame, you should be able to start filtering and cleaning it. And that will be the topic of our, for the next 2 weeks. We'll talk about working with strings, manipulating strings, filtering, aggregating data, using string manipulations functions, as well as dplyr package. So we're done with the first part of our course. Let's do this. Right now, it's 6:55. So why don't you take this quiz right here? 1 second. Something happened. Yeah, take this quiz, please, right here, reading data from files into R. It shouldn't take you more than 5 minutes. And then please take a short break, like for 10, 15 minutes. So we'll continue our agenda at around 7:15, if you don't mind, okay?